So now let's talk about private and public access modifiers. The keywords private and public indicate that those are going to change how item can be accessed, right? And so they determine how easy it is for the member to be accessed. And to be clear, when we say accessing a member, we mean either reading the member's value or modifying it. If you declare a member to be private, then the member can be accessed only from within that member's class. And instance variables are almost always declared with the private modifier because you almost always want an object's data to be hidden, right? You want to control access to it. Making the data hard to access is what encapsulation is all about, and it's one of the cornerstones of object-oriented programming. If you declare a member to be public, then the member can be accessed from anywhere, from within the member's class and also from outside the member's class. And so anything can modify that object's attributes. And methods are usually declared with the public modifier because you normally want to be able to call them from anywhere. So in this example, class A could directly access an object of class B's type X variable, but not its Y variable, because you see right here, X is public, where Y is private, right? And in more current terms, you can think of this in regard to your Facebook profile, right? What information do you want only your friends to see, and what information do you want to make available to everybody on the internet, right? So you lock down the information that you don't want people to see. So this is the same situation, but more to the point, understanding how to properly read and use access modifiers is important when we start talking about using other classes to interface with our object class. And if you notice in the mouse class, there were no main methods. So how do we use the mouse class? Well, we need to use a driver program to access that. And so that's going to show you how we can use public and private to make different methods available to an outside method. In this case, in a different class, we're going to be using the driver class to access our mouse concrete class. So let's go ahead and take a look at that. So here we have the mouse driver class that I alluded to earlier. And you can see here we're getting some user input. Okay, well it's assumed that we're going to because we're using the scanner class, and then we're specifying a growth rate variable, and then we're also instantiating excuse me two mouses anyway, two mice called Gus and Jacques. And so we're going to enter a growth rate, percent of a growth rate, because it's double, and then we're going to take that growth rate and set each of the mice's growth rate to whatever we input. And then we're going to grow the mice. Okay, we're going to grow Gus twice and Jack once, and then we are going to print out what their values are. So you can see here that this is actually, this driver program is using our mouse class because we're creating a new object and we are assigning it to the Gus variable, and then we're going to actually use that to execute. So let's go ahead and we're going to compile it, and then we're going to run it. And you can see here, once I get my window moved over, all right, enter growth rate in percent. We're going to say, hey, they're going to have a 10% growth rate, right? So you can see here, at age 1, now notice that the display is kind of not very good because it doesn't tell us the mouse's name, right? It just says age 2, weight 1. But that's because we ran Gus twice. So Gus is age 2, but Jack is only age 1 because we only ran him once, right? And you can see that the weight was modified by the method that we had specified in the mouse class. Okay, so that's the driver class. This is how it's using the mouse class and executing methods based on what it has available to it. So let's go ahead and take a look at some of the more features that we're going to look at in a object-oriented class. Now, as I mentioned previously, a reference variable is a variable that holds a memory location instead of a value, and we initialize them with the following syntax. we have a class name or the type of the object followed by the name of the variable. And this sets aside enough memory to store an address in memory, and that's it. And in order to create an instantiated object, we must call the class's constructor using the keyword new. And you saw this in the mouse driver program. The new keyword will reserve space in memory for the actual object and return the memory address of where the object that just got created resides. And this address is what is assigned to the reference variable that we just created in the line above. So let's take a look at a concrete example of this. Here we are declaring a reference variable called Gus, and then we are instantiating it with a new mouse object and assigning the memory location of that new mouse object to the Gus variable, right? And just as we've seen before, we can combine these two steps into a single initialization step. Once we have an instantiated object, we have access to all of its public variables and methods. And to use an object's methods, we say that we are calling or invoking the method. So if we look at the mouse driver class, we create a mouse object and then call its methods as seen here. We created a mouse called Gus, and now we are calling its set%growth_rate method, passing in whatever growth rate we gave it. And then here we're using the object of type mouse, Gus, and we are calling the grow method. And here we're calling the display method. A calling object is the object that appears at the left of the dot in a call to an instance method. So take a look at this code. Where are the calling objects? Of course, the calling object is Gus, right? But what you might not have realized is that dot out and standard in are also calling objects. Okay. Now in this code snippet from our mouse class, we have the method grow, and in this method we have this reference. So we're talking about this, right? What the heck is this mean? Well, when it's used in conjunction with a dot and an instance variable, this is referred to as the this reference. And in this example, the this reference is used inside of a method to refer to the object that is calling the method. In other words, the this reference refers to the calling object, which is itself, right? And we have to have a special keyword for this because otherwise we would have no way to reference the calling object from inside of itself. So, which is, I mean, it's really confusing initially, but it's not once you think about it. So think about it this way. How would you tell somebody you went to the store if you couldn't use the word I or my, right? When you see this keyword, excuse me. When you see this keyword, like in this example, think of it in terms of my, as in my weight or my age, right? Because remember, the mouse class at this point, when we're writing it, it has no way of knowing its actual object's identity. We haven't created a Gus or a Jacques yet. But what we're saying is once you are created, this method, whichever object is created, its weight, right? This weight belongs to itself. And so if we create 3 mice, each mouse is going to have its own weight variable. So whichever one calls this method, its weight is going to be updated. So hopefully that's a little bit clearer. This can be kind of confusing when you first get started, but it's a very critical component that you need to understand when dealing with object-oriented programming.